in an early model JK with a 5.3 LS engine. In the last video we talked about the Gen 5 engine, and we're going to talk a little bit about the Gen 4 engine because it was a stepping stone to the Gen 5. And as indicated in the last video, we have to go all the way back to the 1950s when the small block engines were really becoming popular. In the 1950s, right after World War II, a lot of technology had come out that trickled down into the consumer market, and we were starting to see overhead valve V8 engines for the masses. Chevrolet, Ford, and Chrysler all came out with V8 engines that were affordable and had more power than their predecessors. Of course, high-octane fuels, better lubricants, and better metallurgy became part of the automotive industry. As we discussed in the last video, as higher compression and overhead valve heads became available to the masses, the power of these engines increased.
These engines were starting to put out 1 horsepower per cubic inch. There's an argument what was the first engine that did that. It could have been the 283 Chevy. A lot of guys say it was the Chrysler 300, but whatever. We were exponentially increasing the horsepower of these engines. So when I say the small block Chevy was advanced, for its day it was extremely advanced. If you look at the design of the crankshaft and the way they set up the lubrication and the cross drilling, it was a marvel that they could keep these engines with that kind of horsepower in these vehicles for the long term and warranty them and putting out the power that they were putting out. Now I think here's where the Americans and the rest of the world kind of separated. The Americans were always about simple, rugged, overhead valve or flathead engines. The V8 pretty much dominated in America for the performance vehicles. Ford, Chevy, Chrysler, they all had them. The 340s, the 360s, the 318s, you name it. Ford had the 400s, the Cobra Jets, the FJs. GM basically had the small block and the big block, and the big block was a semi-Hemi where they tried to get a little more power by canting the valves, where the small blocks had the valves all in line. Bottom line is with overhead valves you can make a lot of power. They went to the 202 intake valve on the small blocks by the 1970s, which allowed more air into the intake. Then we went to bigger cams, then we went to roller cams. But really what the Americans did to get more power was just increase the size of the engine. We went from a 265 to a 283 to a 302 to a 305 to a 327 to a 350, 383, 400s, 402s, 427s, 454s, you name it. We just kept getting bigger and bigger. We ended up with a 502 cubic inch engine with overhead valve, serpentine belt, fuel injection, which was a very powerful engine, but really it was just a monster engine. On the other hand, the rest of the world, especially the Europeans, went with technology, and there was reasons for that. English for a long time were taxed on the size of the engine or the bore and the stroke, so small displacement engines had to get more powerful, and they did it through dual cams, overhead cams, 4 valves, multiple valves. Japanese did the same thing. So while the rest of the world was using these technologies, the Americans just kept making engines bigger. By the time the Gen 3 engines hit in the late 1990s, I think we realized that we couldn't just keep making these engines bigger, that we had to advance the technology in these engines. So we went to a lightweight aluminum construction. We spent a lot of time with the combustion chambers to make them as efficient as we could, but we didn't drop the overhead valve architecture. We didn't drop the V8 architecture. We stayed with a large engine. And the Gen 3 engines were a good go-between. We didn't have cylinder reducing technology like multiple displacement. Now GM did have it. They ran it in the 1980s in the Cadillacs, the 468 engines. But unfortunately that technology just really wasn't rationalized at that point. It wasn't until the Gen 4 engines that AFM really became functional in my opinion. So the Gen 3 engines were the basis for the LTs and the Gen 4 engines obviously. What the Gen 3 engines introduced was higher compression, lightweight construction that was strong, skirted blocks, which means the block drops down below the crankshaft, cross-bolted so we can put more horsepower out. It was an amazing improvement over the small block. If you take a 5.7 liter K motor from a 1990s Chevy pickup, they were putting out under 200 horsepower. They were relatively heavy. The earlier ones ran throttle bodies, which were fuel injection. And here's something else you have to consider. When you run a throttle body, essentially all it is a carburetor, so you're still pushing that fuel through an intake. And if the intake's cold, the wetting of the walls and the cylinders and the intake are going to reduce efficiency and horsepower. Throttle body wasn't the ultimate. By 1996, with the feds mandating onboard diagnostics, misfire detection, we went to sequential fuel injection. One of the main reasons we went to sequential fuel injection was so that we could shut cylinders off that weren't working, that the operating system determined was misfiring. By going to sequential fuel injection with the small and the big block Chevy, it did improve the efficiency and the horsepower a little bit, especially cold starts and drivability. I remember back in the 1970s and 80s wheeling with carburetors, it was a pain in the butt because when you went up steep inclines or declines, the carburetor had a tendency to flood out. Yeah, we did the spring-loaded needle and seeds. The Carters and the Rochesters worked better than the Holleys, the center sprung Holleys, but it was the reality of it. With fuel injection, as the Germans found out in World War II, you can run the things upside down. The fuel injection is going to keep running. So by the 1990s, when the Feds came out with OBD2 and a small block was greatly improved, a lot of you guys remember the LT1s from the mid-90s, probably one of the pinnacles of the small block Chevys, even though I did not like the OptoSpark. It was very troublesome. They realized that they had to do something better. So the Gen 3 came out with the all-aluminum construction, higher compression, better combustion chambers, and if you take a 5.3 from the early 2000s that was the standard engine in a mini GM truck, we were pushing over 300 horsepower. In fact, we had done several swaps with the early LM7s and L33s. We took out the 5.7K motors. We gave these engines over 100 horsepower more, and the economy on average improved 3 to 4 miles to the gallon. That's huge, and that's what the Gen 3 motors did. The Gen 4 engines were an extension on that. The Gen 4 engines added technology like variable valve timing, which helps control cylinder pressure. Now it is discrete, which means you basically only have it parked in an open position, but it was a start. The Gen 4 engines also offered cylinder displacement technology, whether you want to call it active fuel management or displacement on demand. It allowed us to keep a larger displacement engine like a 6.2, effectively reduces displacement in half. So if you can take a 6.2, cut it down to a 3.1, we reduce what are called pumping losses. Pumping losses are when you have a large displacement engine, it's most efficient at wide open throttle. I'll say the dark days of the 1970s, because in around 1970, the feds really started to get invasive with emissions. Insurance companies were getting concerned about the horsepower levels that the engines are putting out in the 1960s. So the 1970s and 80s were really the dark days of engine performance. Emissions devices like catalytic converters came out in the mid-70s. Air injection systems or air systems, EGR valves really choked these motors down. These motors were not designed from the ground up for this technology. Now in the old days of the small block and the big block, they ran what were called road draft tube, which basically vented the crankcase to the atmosphere. When they went to the positive crankcase ventilation system or PCV, which scavenged the crankcase and then reintroduced it in the combustion chamber, that took most of the emissions out of the vehicle. But we still had all sorts of issues with cold start or under a load knock. Like if you're going up a long steep grade, nitrides of oxygen would build up, so the EGR valve was introduced to reduce that. Secondary air systems, the engines of the day weren't that efficient. They were lower compression, so we maybe had 92% efficiency. That meant those hydrocarbons and COs, hydrocarbons meaning raw gasoline and COs meaning partially burned gasoline, would get into the exhaust, and we didn't want to just blow those into the atmosphere. So by introducing air, we completed the fire triangle. If you look at a campfire, you have heat, you have fuel, and you have air or oxygen. Well, what we have in an exhaust manifold is heat and fuel. All we had to do was introduce air and we can complete combustion. So secondary air systems got really complex. We had diverter valves and air management valves, and then you combine that with a catalytic converter, which some of them were aspirated, meaning they put oxygen into it. It really did clean up the emissions of the vehicle, but at the same time it really did reduce performance. Modern engines don't really suffer from that reduction in performance. These engines are designed from the ground up for emissions. Most, if not all, of the Gen 4 and Gen 5 engines have done away with the EGR valves and secondary air systems. And as far as the EVAP system goes, it really has very little to no effect on performance. All that's doing is treating the vapors inside of the fuel tank. You really can't complain about emission systems today, especially in the Gen 4 and the Gen 5 engines. So if we fast forward to the 1990s, the late 1990s, after the Gen 3 motor came out, all sorts of new technologies started to come out of America. Most of you probably know Mercury Marine built the engine for the Corvette, overhead cam, all that. Well, that was a short-lived engine, but it did introduce a lot of technology into the American infrastructure. And by the 2000, when the Gen 4 engines came out, the old overhead valve engines were starting to introduce some technology, and they were not just increasing their displacement. So now if we fast forward into the LTs, we're taking the Gen 4s to a next step. We're raising the compression again. We're adding transmissions that allow more diverse gearing so that you can more effectively get the power to the ground and move the vehicle. We've introduced direct injection, which is a technology that's been around for a long time, but just like active fuel management, it just was never reliable enough in the old days to introduce into a production vehicle. The Europeans did it a while back, but they also had a lot of issues with carbon on the back of the valves and other issues, the nozzles wearing out. But GM has pretty much got it nailed, in my opinion. These technologies have now been incorporated into the good old V8 overhead valve architecture, and it worked. I think one technology that really is overlooked is continuous variable valve timing. Continuous variable valve timing gives us that precision control of cylinder pressure that allows us to run direct injection and get maximum benefit from these transmissions, because rather than transmissions downshifting to get the engines in their power band, the cam can phase. and it's not a discrete phase like it was in the earlier engines where you had to be at a certain RPM under a certain load. This is very precise. You can phase that cam to wherever you want, and you can actually feel in the LT engines that burst of power when the cam phases and the transmission doesn't downshift. And then when you add the extra gears in those transmissions, it means that you're cruising down the road almost like you have a one-speed transmission. Now let's get back to this Jeep. This is an early model Jeep with a LS, and this is an awesome combination. Don't overlook this if you have an early JK. This is a Gen 4 with variable valve timing, discrete variable valve timing. These engines are simple, rugged, reliable, and will run for hundreds of thousands of miles. And with the introduction of the LT, we're seeing the prices on these engines drop. The 6L80 is still a great transmission. It's very strong. It has much better gearing than any of the 3 or 4 speeds from the past. So if you have an early model JK and you want a cost-effective engine,
the Gen 4 LSs still make a great candidate for your JK. I'll be honest, I'm not a fan of the Gen 3 in a JK for several reasons. One, in most cases it's not legal according to the feds because the Gen 3 engines were phased out at about the same time the JK was phased in. And two, they just don't have the technology of the later engines like the Gen 4 LSs and the LTs, and they cost similar to the Gen 4 LS. So I would stick with a Gen 4 LS or a Gen 5 LT. And when it comes to transmissions, you have the choice of the 6, 8, and the upcoming 10 speed. Any of those transmissions are superior to the 3, 4, and 5 speeds that we were running in our JKs in the past. See you next time.